Good morning. So today we're going to review equations of lines, linear equations of lines, and linear inequalities. Okay, so find an equation of a line. You're going to use the formula y minus y1 is equal to m times x minus x1. So you're going to have to know a point that lies on the line, and you're going to have to know the slope. Okay, so you're going to either be given that way, or you're going to be given two ordered pairs. If you've been given two ordered pairs, then the first thing that you need to do is find slope. So remember, it'll be y2 minus y1 all over x2 minus x1. Okay, so either way, you're going to use this formula, this point slope formula up here. Okay. All right, let's look. We have an ordered pair, so we got x1, y1, and we have our slope. So I can just plug into my formula the missing values. So y minus y1, so y minus 7 is equal to your slope, which is 3, times x minus x1, which is a 2. So now we'll simplify them. Say y minus 7 is equal to 3 times x, which is a 3x. 3 times negative 2, which is a negative 6. Solve the equation for y. So you are going to add 7 to both sides. So you're going to get y equals 3x plus a 1. Okay, this one down here is an ordered pair. You have two ordered pairs. So when you have two ordered pairs, the very first thing that you have to do is find your slope. So y2, which is a negative 7, minus y1, all over negative 3 minus a negative 1. So it's going to be a negative 8, turns into plus over negative 2. So your slope here is a negative divided by negative. It's going to be a positive 4. So now you know your slope, and now you know your x1 and your y1. So the second part that you'll do is use the formula. So it'll be y minus y1, which is a 1, is equal to your slope, times x minus x1. So it's going to turn into a plus right there. So this will be y minus 1 is equal to 4x plus a 4. Add your 1, so y is going to be equal to 4x plus a 5. Okay, so the second part of this, the line of best fit. So remember, we use our calculator. Okay, so we're going to get our ordered pairs. Okay, so find ordered pairs. Okay, and then on your calculator, remember, you're going to get a stat. Okay, go to stat, then go to edit. Okay, put in the ordered pairs. Okay, after you do that, you're going to go back to stat. Then you're going to go over to calc. Okay, and then you're going to do one variable. Whoops, no, sorry. That's what we were doing. We're not doing all variable statistics right there. We are doing our linear regression. Okay, looks like this. Sorry. So ax plus b. Okay, and remember, then it'll give you an output. It'll say A equals this, and then B equals that. Okay? All right, so let's look at a problem here. So here we've got a scatter plot. Shows the weight loss per week of a diet. In the graph, Y represents the person's weight in pounds. So Y is equal to pounds. And X represents the weeks. So this represents your weeks. Okay, so find the equation of the line of best fit. So looking at this, we have what's going on here? It's a decreasing, right? So the slope there should be a negative whenever you calculate it. So the first thing I need to do is find my ordered pairs. So at week 0, my weight is 108, 180. At week 1, my weight is 178. At week 2, my weight is 176. At week 3, my weight is 174. At week 4, my weight is 170. At week 5, my weight is 168. At week 6, it's 164. Okay, so those are the ordered pairs that you're going to put into your calculator. Okay, make sure that everything is cleared out. So if there's something in that table, make sure you hit delete, 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 delete to get it all out. So we'll put in the X values, you'll put 0, 1, 2, 3, 4, 5, 6. Then go over to, mine says line 3 at the top. Yours is probably going to say line 2. Then you'll type in 180, 178, 176, 174, 170, 168, and 164. Okay. All right. So now go to your stat, go over to your calc, and go down to linear regression, and you get the formula y equals ax plus b. Okay. So my A is going to be a negative 2.642857143. That is my slope. So I'm going to get y equals a negative 2.64x plus your b, which is going to be 180. Okay, 0.7857143. So 0.79. Okay, so predicts the person's weight after 10 weeks. So that means my x is going to be equal to a 10. So y equals a negative 2.64 times 10 plus 180.79. So negative 2.64 times 10 plus 180.79. So after 10 weeks, if I follow this pattern, my weight is going to be 154.39. Okay, what if I wanted to know at what week will my weight be 135? Okay, at what week would my weight be 135? So that means I would go opposite, right? I would have 135 is equal to a negative 2.64 times x plus 180.79. So you're going to subtract that. So 135 minus 180.79. So it's going to give me a negative 45.79. And then you're going to divide both sides by negative 2.64. So it's basically going to take me, what does that say, 17.34 weeks. So it's almost going to take me 17 and a half weeks to get down to 135 if I follow that pattern. Okay? Okay, so now we're going to talk about direct and inverse variation. Direct variation is going to have an equation. So I'm going to talk about direct right here. It's going to have an equation, y equals some constant x times, or some constant k times x, sorry. Okay, so y, that means that y over x is constant. For all ordered pairs. Okay, direct variation always goes through the origin. The equation always is through the origin. Okay, finding a missing variable, you're always going to do, so if you have, an x1, y1, x2, y2, if you're given an ordered pairs here, then you'll say y1 over x1 is equal to y2 over x2 to find it. Inverse variation. Okay, this one has the formula of y equals, so solve it for y, and it's going to have y equals x over, or k over x. Okay, x times y is always constant for all ordered pairs. Okay, the graph here does not go through the origin, but it's going to look something like this. To solve for this one, if you had an ordered pair x1, y1, and x2, y2, then you would say x1 times y1 is equal to x2 times y2, and you could find the missing piece. Okay, so let's look here. What do these represent? Do these represent direct variation or inverse variation? So let's look. Y equals negative 2x. So that is, it's got a constant k. It's in that form, right? So this represents a direct variation. The b part is y equals 36 over x. So it's kind of in the form k over x. So that would be an inverse. Okay, c part, we've got our ordered pairs, so we would need to figure out what is constant. So I could check by saying 84. Okay, so 84 divided by, so y over x would be, remember, direct. So 84 divided by 12 is going to give me a 7. 119 divided by 12 is going to give me, 119 divided by 17 is going to give me a 7. 140 divided by 20 is also going to give me a 7. And 217 divided by 31 is going to give me a 7. So each one of those, so my k here is going to represent 7. So this is going to be a direct variation. Okay. Multiply those two together would be an inverse, but this one's not an inverse, it's a direct. Okay. So that means that my formula could be y equals 7 times x. Okay. All right, let's look for the missing value here. So this is a direct variation, so finding the missing value here. So direct means that I have my x1, y1, I got an x2, y2. So I'm going to take 14 divided by 5. It's going to be equal to 28 divided by x. So I'm going to solve. So I'm going to have 14x, multiply both sides. 28 times 5 is going to be a 140. Divide both sides by 14 now. So x here is going to be equal to 10. Okay, inverse variation. Inverse variation, so that means that we would multiply these two together. So x1, y1, x2, y2. Okay, so I'm going to say 4 times 12 is equal to 3 times y. And I'm going to solve. So 4 times 12 would give me a 48. 48 divided by 3 would give me a 16 for y. Okay. Alright, let's look at this word problem here. The height of a wave in California varies directly with the seconds that pass by. Okay. At 4 seconds, the wave is 4 feet high. Identify the constant of variation. So it says it varies directly. So anytime with the seconds, so seconds right here is going to be my x. So after that variation, what it says, it's always going to be, that's going to be your x. So then your y is going to be equal to height. At 4 seconds, the wave is 6 feet high. Alright, so at 4 seconds, my wave is 6 feet high. So I want to look at the constant. So what I'm looking for is I want to find k. So k would be y over x. So that would be 6 over 4. So the constant of variation, if I reduce that, that's going to be 3 halves. Okay. The pitch of music note varies inversely as its wavelength. So my x here is going to be wavelength. And my y is going to be the pitch of the music note. Okay. If the tone has a pitch of 440 vibrations per second and a wavelength of 2.4, okay, so a wavelength of 2.4 is going to have a pitch of 440 vibrations per second. Okay. Find the pitch. Okay, so find the pitch of a note that has a wavelength of 1.6 feet. Okay, so we have an inverse relation here. So that means that this is going to be x times y is equal to x times y. Okay, so we'll say 24 times 440 is equal to 1.6 times y. So 24 times 440 is going to be 10,560, and divide both sides by 1.6. So your y here is going to be equal to 6600. So vibrations per second. So we'll have 6,600 vibrations per second. Okay, solving systems of equations, that means that you're going to have 2 linear equations, and you're going to figure out where they intersect. Okay, so there's going to be 3 different ways to solve systems of equations. Okay, you can graph. Okay, you can solve by elimination. And you can solve for substitution. Okay, graphing, you make sure that each one of them is in the form, solve for y. So make sure that they're solved for y. Okay, then you'll graph each linear equation and figure out where the points that they intersect. Okay, elimination, that means that we want to line up our variables. Okay, and we want to solve, make sure that we're going to add or subtract our equations together and get one of the variables to cancel out. That would be elimination. Substitution would mean that, Substitution would mean that I want to actually plug in one of my equations. So I want to solve one of my equations for a missing variable, and I want to plug that in for inside my other equation for the variable. Okay? So there's an ordered pair so there's different types of solutions. You can actually have an ordered pair. That's where they intersect, so there is one solution. Okay. If they're parallel lines, then they're going to have no solution, so they never intersect. No solution means that they would be parallel lines. And infinitely many solutions, okay, would mean that they are the same line. Okay? Okay, so let's solve this equation, systems of equations here by graphing. So they're both in the y equals mx plus b form, so we're going to plot our y-intercept. So I'm going to take that first one and plot my y-intercept, which is at a positive 2. Okay, and then I'm going to use my slope, so it's a negative 3 over 2, so I'm going to go down 1, 2, 3, over 1. Oh, okay. Sorry. Go down 1, 2, 3, over 1. Okay, go down 3, 1, 2, 3, over 1. Down 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. Okay, up 3, 1, 2, 3, over 1. Up 3, 1, 2, 3, over 1. Okay, now let's do the second one. So it's a y equals negative 6, so it's down here. A negative 6, and it's got a slope of a 1. So we're up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And we could keep going, right? Well, where these two graphs intersect is going to be at the ordered pair. Okay, what's that ordered pair? 1, 2 down to negative 4. So where they intersect is going to be at positive 2, negative 4. So that's where they intersect. So they have one solution right there. Okay, so here if I solve this one, I could solve this one by elimination. Make sure that they're in line. Okay, so if I added these two together, I would get x plus x, which is a 2x, my y's would go away. So negative 4 plus a 2 would be a negative 2. Divide both sides by 2. So x is going to be equal to a negative 1. So now I need to solve for y, so it doesn't matter which equation you go back to. Let's go back to that first one. Oh, bless me. Oh, excuse me. Alright, so I'm going to go in for negative 1 for my x. So I'm going to add 1. So y is going to be equal to a negative 3. So my ordered pair here, my solution is going to be negative 1, comma, negative 3. Okay. This one, we're going to solve this one. This one, I have x equals 2y minus 3, and I've got 2x minus 3y equals negative 5. So I could move the 2y to the other side, but it's already solved for x. So what that means is that I could plug this 2y minus 3 in there in the second equation for x. So that means I'm going to replace that x with 2y minus 3. Okay, so just simplify. So we'll have 4y minus a 6 minus 3y equals a negative 5. So we simplify, so we'll get y minus a 6 equals a negative 5. Add 6. So y is going to be equal to a 1. Okay, so we're going to go up here, go back to that 2y minus 3 and solve for x. So we'll have 2 times 1 minus a 3, so my x is going to be a negative 1. So my ordered pair is going to be a negative 1, comma, 1. Okay, good. All right, let's look here. Here's a word problem associated with systems of equations. Okay, and remember with word problems, we used our calculator, okay, to reduce the matrix. Okay, so I don't know if you remember doing that, but let's set it up first so we can get it situated here. So Aaron bought 4 jars of jelly and 6 jars of peanut butter for $19.32. Adam bought 3 jars of jelly and 5 jars of peanut butter at $15.67. Find the cost of each. So we need to we'll let our first variable equal our jelly. So x is going to be jelly, and y we can let be our peanut butter. So Aaron bought 4 jars of jelly, so 4 times x, plus 6 jars of peanut butter, so 6 times y, is going to be equal to 19.32. Adam bought 3 jars of jelly, so 3x, and 5 jars of peanut butter for a price of $15.67. Okay, so remember, we could do mathematically, we could solve this, okay, but to help us out a little bit, we can use our matrix, okay, and remember our matrix takes the variables, so each one of the variables right here, okay, 3, 5, 15.67. I'm using your memory. Can't lose it. Math you have to continue to use. Okay, so this would be our matrix. So how I would input that into my calculator, I would go second, and it's that little, mine's on the little x to the negative first power. Okay, go all the way over to edit. Okay, so find your matrix on your calculator, and mine is at second. Okay, so mine is at second. X to the negative 1. Everybody's is a little bit different because above that it says matrix. Okay, and you're going to go to, it's got a little an A like this. Okay, make sure that your dimensions of your matrix are a 2 by 3 because I have 2 rows, right? I have 2 rows, and I've got 3 columns there. So make sure it's 2 by 3. Okay, so now we're going to input all that. So 4, 6, 19.32, 3, 5, 15.67. So make sure you hit enter every time. Okay, so now you're going to go back to second matrix. Okay, so go back to second matrix, and now you're going to calculate. So that's how you input the material. Okay, so now you're going to go find R, E, F. Okay, under math, so second matrix, then you're going to go to math and type in R, E, F. Okay, mine's that letter B down there. So you're going to hit enter. So second matrix, over to math, down to R, E, F, and then go back in. So then it'll pull up this once you type it in, and then type in second matrix again. And then pull in, so your name, it's already there, so name A, because that's where you put all of your 2 by 3 matrix in there, and then hit enter. And enter again. Okay? So when you do that in your calculator, you're going to get a row reduced matrix. So you're going to get it solved. Okay, so in your row reduced matrix, you have this 1, 0, 1.29, 0, 1, 2.36. So that means that this right here, it's row reduced. We have a 1, so that represents the cost of your jelly, and this represents the cost of your peanut butter. So your jelly is going to be $1.29, and your peanut butter is going to be $2.36. Okay? Alrighty. Linear inequalities. Okay, so here we're going to have an inequality, so we're going to have an inequality sign. Okay, so anytime you are going to have a less than or a greater than sign, you will have a dotted line. Okay, and a greater than, equal to, or a less than or equal to, you will have a solid line. Okay, so you're going to solve these equations. So here you need to always make sure that it's got a y on that left hand side, and everything else is going to be on your right hand side, because you're going to graph it just like you would a y equals a negative 3x minus a 1. Okay, so you would graph your y-intercept and then use your slope to find another point. Okay, the other thing that we have to know is that we talk about our shading. Okay, so dotted line, solid line, and then your shading. Oops. Okay, if it is a greater than or greater than or equal to, we shade above the line. And then if it's a less than or less than or equal to, we shade below. Uh-oh. Pen's dying here. Okay, let's do an example here. So y is greater than negative 3x minus a 1. So negative 1, we will draw we'll plot our point, because that's our y-intercept at negative 1. Okay, and then we'll use our slope to find another line, another point. So -3 is our slope. So we're going to go down 30, 1, 2, 3, and over 1. And we can go up 3, 1, 2, 3, over to the left, 1. 1, 2, 3, over to the left. Oops. Okay, so this there. Okay, so now this is going to be a dotted line here. Okay, so we're going to have a dotted line. Okay, and this y is greater than -3x minus 1, so we will shade everything above the line. Okay. Systems of linear inequalities, you will graph each one. Okay, and the solution will be the shaded region where they overlap. Okay. Okay, so get this in each one of these. So the first one, we need to solve for y. So y is going to be greater than or equal to, if I move the 4x to the other side, it's going to become a -4x plus a 4. Okay, the second one there, same thing. So I need to solve that one for y. So if I move the 3x to the other side, it's going to be a -3x. Okay, I'm going to divide by -2. So when I divide by -2, what happens? The inequality sign changes. So I'm just going to change to 3, a less than or equal to positive 3/2 x, and 14 divided by -2, which is a -7. Okay, so now let's plot each one of these. So y is greater than or equal to a -4x plus a 4. Okay, so I'm going to plot it at 4. So my y-intercept is going to be at 4. Okay, and then I'm going to go 1, 2, 3, 4 over 1, down 1, 2, 3, 4 over 1. Okay, let's go again, sorry. 1, 2, 3, 4 over 1. Sorry. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Okay, so this is going to be a straight line here. Oops. Okay, sorry, it jumped on me. Okay, so y is greater than or equal to, so it's everything over on this side. Okay, alright, let's do the second one. So this is going to be y is less than, okay, 3/2 x minus a 7. So at -7, we'll have our y-intercept at 3/2, so we're going to go up 1, 2, 3 over 1, 2. 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 Down 1, 2, 3 over 1, 2. Okay, so now that linear inequality is going to be a dotted line. Okay, it's going to be a dotted line. Sorry. Oh, these are funny. Okay, dotted line. So it's y is less than 3 halves x minus 7, so it's going to be everything below. So the area of where they intersect is right here. Okay, so where they overlap. Okay. All right, I hope that helps. Y'all have a great day.